Mr. Hudson got hurt. Ha 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 ha. Yeah, then the worst thing was my elementary teacher at the time wouldn't let anyone help me at school, so I had to try to do everything with one arm. So we had desks with like our books, because it was elementary school, so I had to hold my desk up with my head while I got my books out. I'm in the fourth grade. I was an adventurous kid. I still remember I was 10. You can't remember when you were 10? Yeah. Are you just going to start forgetting your memories? You break an arm, that's a memorable event.
I've never broken a bone in my body.
You better knock on wood or something. That's not wood. This might be wood. This is wood. You better. Laviva comes back next week with 2 broken bones. Okay.
Laviva?
No, sorry, I did say Laviva. I know you are. My brain is just broken at this point.
Oh no, you got this hard.
I'm sorry. Maybe somebody dropped you on your head. Alright, let's do this thing. I have given you plenty of time to get in here and get rolling. It is almost 10 after 9. We gotta roll. So today, more kind of jumping around, randomness, whatever. Those 6 problems are strategically chosen as your homework. You'll do a little bit of angle work, a little bit of probability work. I think I skipped over the mean, median, and mode because I know those take longer. You can do that if you want some more practice with the data sets. Again, those 6 are the minimum. You can do as much practice as you want to prep and make sure you're all comfortable for next week. So when we start, where's your graph paper? What are we doing? Brendan, you've been in here for a long time, like longer than anyone. Why do I have to like invite you to get ready to learn? When we talk about angles, everything that we talk about is dealt with in degrees. Now, it took me a long time to really appreciate degrees. Now, big difference here. What degrees are we not talking about? What degrees Celsius? Like temperature, right? Yep. So there's degrees in temperature, and that in itself is part of a scale. The reason we're calling it degrees is part of a scale. But then we also have degrees dealing with angles. So if you watch the X Games or anything else, hopefully you're comfortable with the fact that if I start facing you, and I were to spin around once, I've gone 360. And if I keep going, I've gone 720. And if I keep going, anyone know the next one?
A big number.
1080. And then we can keep, so every time we go around it's 360 degrees. Right, but most of the time when we're working with angles, we're dealing with less than that. And most of the time, it's even less than half of that. Anyone know why? What's the angle that would go from here to here? 180, but what else is it called? No, and that's the tricky part here. So everyone on your paper, I'm going to flip screens real quick. Draw a circle. Best you can. I know circles are hard to draw. Draw a circle best you can. I'm going to cheat. Don't be mad. You can grab a shapes template really fast if you want. Hey guys. You have 15 seconds to have whatever side conversations you feel necessary. Then I need your attention for the next half hour. We gotta roll. So take your 15 seconds. Whatever you gotta say to your neighbor, whoever kissed you over the weekend, whatever happened, deal with it right now. Whoever had their heart broken.
I used to sing a song when I played
Put a center in your circle. Now, in a circle, and the base of all of our degree work is that an entire circle has 360 degrees around. Whether you label that on the inside or whether you label that on the outside with like a start and a stop point, if that's 0 degrees, we also call it 360 degrees. We can also call it 720 degrees. We can also call it 1080 degrees, and that deals with every time we go around, right? So once versus twice versus every time we circle. Now, while that's great for the X Games and Tony Hawk trying to spin around a whole bunch of times up in the air, which is sad because y'all probably know Tony Hawk is an old guy, not the first pro skater to do a 900. He set a world record. He was the first skateboarder to spin around 2.5 times on the vert ramp, which was really impressive. Yeah, it's okay. What I'm saying is it makes me sad because I start to feel old because that was a big deal when I was a kid. He like broke the world record. Sorry, Mr. Hudson. It's okay. Time marches on.
You're very young.
You know what's
No man can stop it.
9.
Y'all know okay, so sad true confession. I turned 30 on the last day of this month. So there we go.
My mom's 31.
Draw a straight line on your paper. Draw a straight line on your paper.
You're like a child. That's what my mom said. Wait! No! Wait, should you still be? You're not that much younger.
I'm actually truant right now. They're looking for me. I'm missing my AP bio class. How many degrees are in this, which we need to label? This is a straight line. We also call this a straight angle. Now, lots of people will have an issue with something being called a straight angle because in your brain, you're thinking angle has to be something that's like bent or like a corner in a room or like something that has, you know, like the angle. This is an angle. An angle is defined by any two rays, right? Ray going that way, ray going that way, where we can measure the degrees to go from one ray to the other ray. So if I have a straight line, how many degrees should it be from this ray going out this way and that ray going out that way? 180 degrees. Now moving down our range of angles, if I go from a straight angle, instead, and look at everything it's probably, my lines up here probably aren't perfectly straight.
That looks confusing.
Now, most of us will remember this from elementary, 5th or 6th grade. You can play with the putty as long as you're taking notes. I don't care. Now, don't share. If we haven't talked about this in a while, the thinking putty stuff, I don't really have an issue with it. Don't share it, though. It's a bunch of germs. Okay, if you keep your germs, whatever. It's like you picking your own nose. It's gross, but it's your germs. Now, if you've just shaken hands with someone, don't pick. I'm just saying, don't share it. Like you wouldn't let someone else pick your nose, right? Okay. Yeah.
You shouldn't let yourself take
Ava, I'm trying to get a point across. Like sharing that putty is exactly like.
No, I'm not disagreeing with you.
I know it's gross. You made a face because it's gross. What do we call this? Between 90 and 180 degrees.
Right angle.
Not right angles at 90.
Obtuse.
Obtuse. Guys, so this tells me that we need to notate that this is obtuse.
Wait, this is.
We had a karate lesson on this. Obtuse.
Yeah, now somebody just said it. Right. Now that we're in middle school, we don't make you get up and act things out goofily.
I'm just saying.
I agree with you, but that's why you did a karate lesson on it. So I want to reiterate, we're trying to squeeze in as much learning as possible this week. it's gonna feel different than our like the rest of the year because there won't be as much of that like exploration, investigation, like work on this for 5 minutes. I'm trying to make sure that we know certain things before we get to the test.
Oh wait, doesn't class end like in a month?
I mean, kind of. Yeah, I mean, really our academic school year only goes through April. May travel and May term and all sorts of special stuff.
Month. In third grade, we were learning about this, and I thought that the opposite of an acute angle was an ugly, and I was really confident in my answer.
I mean, it would make sense, right? The opposite of acute angle and ugly angle. To be a right angle,
Exactly 90 degrees.
it is exactly 90 degrees.
I knew that, Mr. Hudson.
Guys, please make sure if I put it on my screen, you have it on your paper. Now, a right angle, when you want to test if something is a right angle, what do you have in front of you that involves a right angle? A piece of paper, right? Your piece of paper has 4 right angles on it. So, if you are looking at your textbook, or a computer screen even, and it says estimate, is this a right angle or bigger or smaller? Okay, literally, I just pick up my piece of paper and I put it on the angle, and I see, does it match the corner? Is it smaller than the corner? Is it bigger than the corner? So we talked about bigger than the corner, right? All of these out here in this range, if I start right here and I measure out that way, all of these are like, this would maybe be 100 degrees. This would maybe be like 130 degrees. This would maybe be like 100, probably more like 160. But all those are between 90 and 180, right? Exactly at 90, we can show that either by doing this, and we can label it 90 degrees, or the shortcut to show that, this box. So guys, on the test, they might very well throw you an easy question. They'll show you an angle with the box and say, what's the measure of this angle? More likely, they're going to throw you a question where it has another ray in here. It involves the box. But then they say, if this angle is 50, what is this angle? How would we figure that out?
40.
How do you know?
Because it's a right angle, so it's exactly.
They have to add up to that, right? Now, we'll talk about that special relationship here in a minute once we get done with our names. Obtuse is bigger than right, smaller than straight. So guys, I think most of us should have this written down. Give me your eyes for a second. If it is a right angle, it's not obtuse or straight. Right? If it's a right angle, it's not obtuse, it's not acute, it's a right angle. If it's anywhere out here, that's obtuse. But then if it's anywhere over here, that's acute, which we're about to talk about. That's our next.
And the middle line is exactly the right angle.
That's the right angle, yeah. So it cuts it between acute and obtuse. So then, acute angles, please go ahead and write that down. Easy. Smaller than 90 degrees. So anything from your tiny angle of, you could hypothetically say this is 1 degree. Yeah, except you wouldn't be able to draw it. All the way up to an angle that looks like it might be a right angle, and they tell you it's an 89 degree angle, still acute.
That's aggravating. Why would you? What?
Well, it's like 89.9.
That would be exactly 89.
Oh, it could be 89.9.
So I just said
And it's still not a right angle. If it's smaller than 90, it's acute.
America has gone downhill.
No, that's everyone. That's the globe. That's the world. Geometry is pretty much like, we all agree on geometry.
I love this stuff. It's so easy and fun.
Ava, lots of investigation and testing. And like hypothesizing. So a mathematician would say, what if we say, and then they test a bunch of things, and it either works or it doesn't. And if it doesn't work, you go back to the drawing board.
Oh boy.
Ava was mumbling to herself, like, how'd they figure this out? Like, years and years and years of testing and trying stuff out.
Wait. Remember having that guy that was solving like the world's biggest math problem?
I'm not sure which you're talking about. There's normally a lot of different things like that going on. All right, hold up. Are there questions over this vocab that we just wrote down, starting with the fact that a circle has 360 degrees, and then we go to a straight angle, an obtuse angle, a right angle, or an acute angle? Any questions on those definitions? Sky. Your hand's up. Okay, so now we have more to talk about with our vocab. We have two special angle pair relationships. So if you could draw a little squiggly line or something and write angle pairs, then I'm going to ask that you split your page, actually. I hate your attitude.
That's not a roast. You people are just so sensitive.
You're also just used to your teachers not saying just like...
No, I have outclassed Miss Whitlock. She says stuff like that all
No, she doesn't. You say something like that to her.
I realized a year or two ago it would be much easier if I just said what I thought and was honest with my classes.
If I was honest with everybody in the world, I'd be in jail.
All right, so split your page. Split your page. The two special...
Oh my gosh, Aiden.
Can we not right now?
The two. Notice how this also makes quiet coyote. Special angle pair relationships are complementary and supplementary. Now, I've dropped these words a couple times this year and told you don't have to remember this. You don't have to know this right now. At this point, we want to try to remember them. Anyone remember what it means for two angles to be complementary? Riley? Not opposite. That actually doesn't matter. You're thinking of a different angle pair. These are the ones that have special sums. There are other special angle pairs that we're going to talk about. These two go together because of how they relate. Under both of these, write sum two. Hey Aiden, did you write sum two on your paper under both of these?
That's what I was doing.
Yeah, you're not
I already
listening.
have complementary supplementary.
I know, but I need you with me 100%.
But then she said something that made me.
This whole week, guys, you need to be with me. If you can't deal with who you're sitting next to, I'm going to ask you to move. If you can't do what we're doing, I'm going to ask you why. Okay, so things like that need to be kept to yourself. Complementary angles. Now, this is going to be dumb, but this is how I get you to remember things. If you want to make a good impression on people, and you want people to like you, especially in a new setting, like Ethan, that's a nice hat. Joey, I like that you're wearing pink today. Aiden, I like that your hair has that perfect swoop. Like, to compliment someone is the right thing to do. Complementary angles have the word complement in it.
They're perfect.
If you complement, take this down.
Alright.
They add to 90. So two angles, I need you to show these examples on your paper, such as 40 and 50 when they're connected, or, and this is where people, like, if you're not paying attention, you won't realize it's still okay, two angles that are disconnected, a 40 and a 50. Both of these are two examples of complementary pairs. They do not have to be connected with each other. So these, if I add them together, 40 plus 50, do they equal 90 degrees? Yeah. If I add these together, well, that's easy to see.
Oh, that's easy. Okay.
So it's easier when they're adjacent. But still, if you are given two angles, so here's my concern. On the test, I would not be surprised if they said these two angles are complementary. What is this one? And if you don't remember what complementary means, you're just going to be like, yeah. Complementary. To compliment someone's the right thing to do. I know it's super cheesy, but hopefully that will get in your head. Now, anyone go to the Arnold this year? Arnold Sports Expo? You walk around there, you'll see guys that are so jacked up they can't get their arms down to their side.
Love that.
I'm serious. So, here's the deal. To get there, they probably took
Supplement. Steroids.
You're not wrong, most likely. So, think of some big meathead, right, walking around the Arnold. His arms are so big he can't even put them down. If my arms were so big I couldn't put them down, and they made a straight line across, please write this down. So, supplementary angles, you take supplements to get bigger.
I take vitamins.
Guys, I need your attention this week. I'm going to try to give you memory tricks and try to make some things funny, but I need you to not, like, explode and go way off here. I need you to come back quickly. So, just like complementary, they could be connected together, and say you were given an angle of 40, what would add to make that 180? What should this side be? 140. And you could also have these disconnected. So, like, what if they gave you a 10-degree angle? What other angle would you need to be supplementary with 10 degrees? 170.
What?
Yeah, because they have to sum to 180. So these are both examples of supplementary pairs. They can be connected, which makes it easy to see, or they could be disconnected and you're just told that they're supplementary. Yes?
Okay, so are they always going to tell you that it's supplementary, or will they just give you numbers and then you have to tell them?
Yes. So either situation. So if they told you, here's two angles, 10 degrees and 170 degrees, what special relationship do they have? It might be a short answer response, where they want you to write just whatever you want, and you could say, together they make a straight angle, which is also called a supplementary pair. And that would probably get you, like, all of the points for that answer. If you just said supplementary, you'd probably get, like, 2 out of the 3 points or something like that. I don't know. Yeah, they have specific, like, keywords they're looking for. Guys, you can never give too much information unless it's wrong. Don't start making stuff up, but if you have time to write more on the test, do so. Joey? I don't think spelling counts on the math test. Yeah, I think spelling matters for ELA, but I don't think spelling really matters on the math test. Now, try to spell as best as possible, of course, because if the grader can't make sense of what you wrote, they can't grade it. So your spelling has to at least be close. Now, there's really no memory trick for this. So I just got to give you the vocab. Please write down adjacent angles.
Wait.
I'm sorry that there's no real memory trick for this.
You just told us.
Supplementary is basically things that connect to the obtuse.
Add up to 180.
Add up to 180.
Yeah, careful about the obtuse.
Add up to
Add up to straight.
And then complementary is add up to straight.
Add up to 90. Complement is add up to right. Add up to 90 because complement, right, the right thing to do. Supplementary, you take supplements to get bigger. That's 180. Now, adjacent, we just gave examples of adjacent or not, right? Adjacent, these examples down at the bottom, adjacent versus not. Adjacent versus not. So the technical definition, because this gets a little weird, is angles that share a vertex and a ray
But cannot what?
Be separated.
no, they have to be touching, right, to share that side.
But they cannot be separated.
Inside the other. Or inside each other, or the other. I don't know exactly what you want to say.
But you just said that those were
Uh-huh. So, that's the difference between what angles are we looking at.
But you just
So, Ava, I know what you're thinking. Can I explain? Can you not overreact before I explain?
Oh, okay. I'm listening
Do you
to
hear it? You can hear how you're overreacting. If I look at this whole thing as an angle and then put this inside, not adjacent. However, if I look at this angle and then this angle, green is here, yellow is here, they're adjacent. However, green is not adjacent to blue and yellow's not adjacent to blue because they're inside of blue. Yellow is adjacent to green because they're next to each other. They're sharing a vertex, they're sharing it aside. So yellow really technically needs to scooch and green needs to. Now, yeah, so we know about blue. Blue can be involved. We can talk about the blue angle, but it's not adjacent. Here's the other way to think about it. If one of the angles ate the other one, anyone know the Cinnamon Toast Crunch commercials where the Cinnamon Toast Crunch? If one of the angles is a cannibal, it's not adjacent. So think about it like this, and this will be gross, but maybe you'll remember this. My neighbor and I, our properties are adjacent. We share a property line like the property I own, I'm adjacent to my neighbor. If I eat him, he no longer exists. We can't be adjacent anymore. And I'm going to jail. So, if one angle has consumed the other, they're not adjacent. So you might draw a little picture here. Green is adjacent to yellow, but not to blue. Now here's the tricky part. Green is adjacent to purple.
what in the world?
Because green,
Where'd you have purple from?
I just made it up. But if I drew another angle that went out this way, purple goes this way, it uses this side, green and purple both share that side. They both share that, they're adjacent. But is purple adjacent to yellow? No. Hold up. Is purple adjacent to blue? Yeah. Because remember, blue, the light blue, right? Remember, blue didn't move. Blue has been here all the time, the right side of the right. So,
Wait.
hey, quit overreacting. What questions do you have?
Let's climb my bodies and take a breath.
Skylar.
So, but blue is in between green and purple, so then they wouldn't be touching.
Reset it in your brain. If I made this angle is purple and this angle is blue, and I say this is angle purple, this is angle blue, or I can say this is, it doesn't matter where I measure it from. So this is the one on the left, this is the one on the right, they are adjacent.
But then it wouldn't be adjacent with green.
Right, correct.
But you said it was. Yeah.
Wait, purple is adjacent to green always. Because remember, purple, I'll draw these separate to make sure that we understand it. Purple was right here, right? That was purple. And green was right there.
But blue's in between that.
That blue doesn't matter when we talk about purple and green.
Yes, Skylar.
But we were
doesn't
talking
matter.
about purple, blue, and green.
You can't talk about three at the same time.
What?
That might be where if I was talking too fast, when we talk about adjacent, we're talking about adjacent pairs. Now, if I try to look at purple and yellow,
They wouldn't.
correct, because purple went this way,
And yellow isn't like.
and yellow, this might be hard to draw, yellow goes this way, and here, notice how there's a gap. Here's my yellow angle.
But they're still touching.
You're correct, but do they share a side? No. Guys, this is great conversation. Keep pushing back at me if you don't understand it.
They share a little
These,
corner.
they share a vertex, but they don't share a side.
Oh, so they always, if it's adjacent, it needs to be shared at the side. And it needs to have two colors that are shared
And
to
it
the
can't
side.
be inside of each other. Yeah.
Okay, that makes so much more sense.
More questions. Hit me. Come on. This is what we're trying to do today. Just get this learning down and just, yeah.
Okay, so I'm actually Hush. Anyway, so use an angle so the connection to green because like it's hitting green because the green is against it.
Yep, because we have this shared vertex and
Blue's
this
actually
shared
green,
side.
Purple's actually green because purple's over blue, so they're both connected.
So here, check. Shared vertex, purple, blue. Shared side, right? Purple, blue. They,
But it's touching the bottom of the other one, so how is it not connected to yellow?
they only share the vertex. They don't share the side. Essentially, guys, for angles to be adjacent, you have to be able to draw both of them by only drawing 3 lines. This might help you. Give me your eyes for a second. For angles to be adjacent, I have to be able to draw both angles with 3 lines. 1, 2, 3. Right? 1, 2, 3. 1, 2, 3, 4. It doesn't count that this is one straight line. You come from the vertex. Right? So this takes 4 rays, not adjacent. Are we cool on what adjacent means? Now, a relationship that involves the complete flip of that. Please write on your paper. Draw any intersection of 2 lines. It doesn't really matter. Now, one thing that drives me crazy, that is pretty much the reason I don't have any rulers left, is when you guys make helicopters. Now, what you don't realize is you're actually setting up a mathematical relationship.
Helicopters, what?
I'm very confused right now.
So whenever we talk about getting rulers, everyone's always like, whee!
I used to do
So,
that.
give me your eyes. What you don't realize is when you put the ruler on a pencil, you created a vertex. I forgot. That's not the whoa part. So, now I gotta use these to make it bigger. But if I put 2 rulers on this and do this, I have a vertex and some rays and I create some angle relationships. So I'm gonna switch to here so you guys can actually see it. If I move just, let's stick this straight up. If I move just this, what else do I know is gonna move? Can I move this up without this moving down?
Whoa!
You can if you snap it in half.
That's besides the point.
It's the same line.
No, because they're together.
Because they're connected.
So wait, can I make any hypothesis about the relationship here and here versus the relationship here and here?
They're not
Yeah,
equal.
they're related. Those ones are smaller, those ones are bigger.
And then as I make my smaller angle bigger,
But you can change that.
Now those are equal.
About.
But now they're not
Now
equal.
it's not equal anymore.
Not equal.
It's an alligator mouth.
But wait, what?
you have this on your paper, right? The vertical angles theorem, which is like a mathematical fact, essentially says angles made of 2 straight lines will be equal to each other. So if I call this A and this C, angle A will be equal to angle C always, no matter what. And if I call this B and this D, angle B will be equal to angle D always, no matter what.
Because they're connected together. And if you move things, then...
And we have a really clean way to say the because. Ava, I agree with you. We have a really clean way to say the because. Check this out. Once you write that down, give me your eyes for a second. What could we say about angle A plus angle B?
It equals a 180 angle.
It's 180, right?
Yep.
What could we say about angle B plus angle C?
It's 180.
I'm talking about my laugh. I'm talking about my laugh. Jeez.
Hey, I'm still writing, which means you should probably still be writing, unless you could guess what I was going to write.
Wait, but that's basic.
But they're
If
all the same.
A plus B is 180, and C plus B
Oh, okay.
is 180,
Yeah. I'm agreeing.
A and C have to be the same thing, because we know B is the same thing. So since this supplementary pair and this supplementary pair exist, we have proof
Oh my.
that angle A must equal angle C because they both have a relationship with this angle B.
Oh, that makes. Wait. So like, it's like B plus A equals 100.
Yeah, we have supplementary pair,
Yeah, like D
supplementary pair.
plus A. Oh, that's what.
And we can do this again
What about D?
if we look at C and D, right? C and D would be 180, right?
And B.
So B and D are the same.
B and D are equal already. We already know that. So if you just do A and C.
Questions
No.
on vertical angle pairs. Natalie, you with me? I see you're having a lot of fun over there. Just want to make sure we got this. Yeah.
But if A and C were not equal, then A and B wouldn't be equal.
Now, the only way for A and C to not be equal here is if the lines aren't straight. If there's something wrong and the lines aren't straight. So be careful. Ava brings up a good point. If they show you a situation where you have a straight line, but then, and guys, don't put it past them to do this, they'll draw a line into here, but then instead of making it straight, they'll do this.
D.
And they'll say like, okay, this is 40 and this is 100. Does this make a straight line? No. So this doesn't have that relationship with the vertical angles because it's not two straight lines. It's a straight line and a broken line.
It's
Right?
a straight line and then two other lines.
Yeah, two other rays, right? We could talk about these as separate rays. But yeah, that won't work. This does not make a vertical relationship. Let me check real quick and see if there was any other vocab we needed to cover.
Oh.
Hey, I do appreciate that, like, this week's gonna be a little bit whirlwind, but you guys are sticking with me to like come along and just do everything we need to do.
This is cool.
So then, real quick, one last rule to talk about when you get in situations like this. One last rule. Hey, and we're gonna do more with this, and I don't think your homework involves this yet. I just want to get you one last rule. Draw a triangle real quick.
What is that?
Roll fast, and I'll get you out of here. And guys, if you want to write out an angle name, but you want to make your life easier, use the angle symbol. So that's the angle symbol, and the little arc on it means the size of. On a computer, that symbol will look like this, because it's cleaner as we write math. We don't want to make it that hard, so we just make an angle and we just draw an arc. We don't care to make it this particularly clean, but on a computer, that's what it looks like.
It doesn't look as pretty as that.
A doesn't like that.
Angle A plus angle B plus angle C.
Equals triangle.
Always, no matter what, equals 180 degrees. And if you don't believe me, I challenge you. Now, don't go and waste a bunch of paper, but I challenge you. If you make a triangle, and then you can start packing up, but I want to show you this before we get out of here. Hold up, don't leave yet. I gotta show you this. Don't leave yet. All right, give me your eyes up on the screen real fast. Real fast. I said don't leave like 8 times, so if that's a surprise to you, it's your fault, not mine. Check it. Here is a triangle, right? It's kind of hard to see because it's bright in here. I have 3 different angles. Hey guys, why am I still competing to talk? I have blue, green, and red, right? My 3 angles. If I tear this triangle apart, no matter what size the triangle is, if I line back up the 3 angles of that triangle, it will make a straight line. So that's your proof for why triangles add up to 180. Hasta luego. See you guys later.